So this is the radian measure. We learned today that, in fact, there's another way to measure angles, which is actually more common. That's why it's the default mode in your calculator, which is called radian measure, not degree measure. And then we introduced what's called the unit circle, which is something that you deal with in trigonometry all the time. A lot of stuff to memorize, or at least just remember how to put it together, preferably. So you will have a unit circle in hand, completely filled out by the time we leave here today. So before we can start talking about the different ways we're going to measure angles, we have to talk about how we put an angle in the coordinate plane. What do we mean to measure an angle which is in the coordinate plane? And we do that by putting it into a standard position. You know, you don't just put it anywhere. You put an angle. There's an angle on the left, which we know what an angle is. We did this in geometry, right? It's two rays, you know, with a common starting point. And how much they open up between them is the measure of the angle. That point where they emanate, the rays emanate from, that's called the vertex of the angle. Right? So if we go to the coordinate plane, we're going to take that angle, or any angle, and we move it so that the vertex is on the origin, and so that one side of the angle is on the positive x-axis. Right? That's called the initial side of the angle. Okay. So this piece of it is never going to change. Okay. Now the other side of the angle, wherever it is, anywhere, you know, in the coordinate plane, that's called the terminal side. So you got an initial side and you got a terminal side. Good. Good. Okay. Now, with an initial side on the positive x-axis, if the angle is opening up, you know, in this direction, which I will call counterclockwise, right? Clocks go like this, so going that way is counterclockwise. That's a positive angle. So positive angles go like this. Negative angles go clockwise. So positive and negative. Got it? Okay, so here we go. This is the fun part for me. So again, now if the terminal side and the initial side are in the same place, then how much is the angle opening up? 0, right? That's an angle of 0, right? What if I went all the way around the circle once? That would be a positive 360. If I went around in a clockwise direction, that would be a positive 360. Okay, what if I went all the way around in a clockwise direction? That's negative 360. But note that in all three cases, the terminal side was on the positive x-axis. So we had 3 ways to say an angle which has a terminal side on the positive x-axis. Negative 360, 0, and positive 360. And in fact, I mean, if this is positive 360, I could go again around and I get a 720, right? You can just keep going, plus 360, plus 360, every time you get to the same place. What if I don't go all the way around? What if I go halfway around? Positive 180, right? Okay, what if I went halfway around in that direction? Negative 180. So positive 180 and negative 180, they're the same thing. Okay. What if I go halfway between 0 and 180? That would be 90. So 90 degrees is straight up and down, which makes sense. That's a right angle. And what would it be if it was halfway between 180 and 360? Positive 270, or it could be negative 90. Right? It could be negative 90, or it could be in positive angles. It would be, 90, 180, 270, 360. Right? So that's the way that these angles work. So let's draw some terminal sides to create the angles that are listed there. So 240 degrees. Which quadrant would that be in? Positive 240. So let's see. If it was 90 to here and 180 to there, 240 would be between 180 and 270, and it would be a little closer to the 270. So how about that? Right? How about negative 50 degrees? Which quadrant are we going to be in? Right. So negative 90 would have been straight down. It's not that far down, so it's a little bit more than halfway. Right? How about 500 degrees? If you get an angle which is not in between 0 to 360, then add or subtract 360 so that it is, and you'll find that position. So, I mean, we know for 500 degrees, we're going to go around one whole time, right? And then we're going to keep going. So it's easier to do this. Just go like this: 500 minus 360 is 140 degrees. So that's what we're trying to find. Where's 140 degrees? This is 90 and this is 180. So it should be between those. Let's see, it's closer to the 180, so it's about like that. So in fact, we went all the way around and then we kept going until there. In the end, it doesn't matter how many times you go around. All that matters is where's the terminal position, with a terminal side. Right, so try to place those three.
So if you're watching this, there may be a little bit of a disconnect here because I actually forgot to hit record after this U-try for a few slides, and somebody reminded me, and I hit it again. So I'm going to try to catch this up. I'm trying to insert what I'm recording now into the file that I already did. I've never done that before, so hopefully it just doesn't mess it up. Okay, so you had to draw the angle in the given positions, in the standard position for these given measures. Again, 65 degrees. That should be between 0 and 90 degrees. I drew my terminal side a little closer to the 90 than to the 0. Right? 300 should be beyond 270, but not to 360. Actually, it'd be like 30 degrees past 270, so there's my terminal side. And 740, again, because the angle is more than 360, I subtract 360, I get 380. Okay, well, 380 is more than 360, so I subtract 360 again, and I get 20 degrees. So in fact, if I was going to find 740, I would go all the way around once, that's 360. I would go all the way around again, that's another 360, makes 720, and then I go another 20 degrees. So all of those angles, right, 740, 380, 20 degrees, that's what you call coterminal angles. Okay, so coterminal angles, again, I didn't realize. I'm going to get to that on this slide. So when two angles, when different angles share the same terminal side, then they're called coterminal. Right, coterminal. So, radian measure. This is already the slides that I annotated before, so hopefully this will still work. But from geometry, you know how to find, you know that the angle, the central angle in a circle, is how many degrees does this thing open up between the sides, where 360 degrees would take you all the way around the circle. Okay, radian measure, instead of using the number of degrees that it opens, it is the length of the intercepted arc, another term that you did in geometry, for that central angle. Now, if the circle is bigger, for the same central angle, you're going to get a longer intercepted arc, right? If the circle is smaller, for the same intercepted angle, or the same central angle, you would get a smaller intercepted arc. So in order to standardize this way of measuring, we need to fix the radius of the circle. So radian measure is when you measure the angle by the intercepted arc when the radius of the circle is 1. Okay, when it's 1. That's what we mean by radian measure of an angle. Now, if I was to go all the way around the circle, we know in degrees that would be 360 degrees. Okay. In order to know radian measure, since radian measure is a piece of the distance going around the outside, then it's going to be some fraction of the circumference. The circumference, we know, has a formula of 2 times pi times r. And since the r in this case equals 1, then the circumference equals 2 pi. So if it's 360 degrees to go around, it's what you would call 2 pi radians to go around the whole circle. Now, radians itself is not a unit. The radian is a unitless measure, which may be kind of hard to see, but just look at this equation here for circumference equals 2 pi r. If I divide both sides by r, I've got 2 pi equals the circumference divided by the radius. Now, if the radius is in inches, the circumference is in inches, and so the units would cancel. You would have no units. So this 2 pi radians is actually equal to a fraction that does not have any units. So this is a unitless number. Sometimes, especially when you first introduce this stuff, you might see them write probably in parentheses RAD to represent radians. But most of the time you don't see that. Right? Most of the time you don't. It would just say 2 pi or however many pi you're referring to. Okay. So we can, we're up to number 11, so I think I need to do one more slide. We can label the axes now. We know that if the initial side is on the positive x-axis, then the terminal side on the positive x-axis is 0 degrees. But also if I go all the way around 360 degrees, I'm at the same place. Halfway between 0 and 360 is 180. Halfway between 0 and 180 is 90. Halfway between 180 and 360 is 270. Okay, now radians. Again, if the angle doesn't open at all, 0 degrees equals 0 radians. If you go all the way around the circle, around a circle with a radius of 1, then you get 2 pi. Right? So 0 and 2 pi are both referring to the radian measure of the positive x-axis. Okay, now if I only go halfway around the circle, right, 0 to there, that's only 1 pi. Right? If I only go from halfway from 0 to pi, that's pi over 2. And if I go halfway in between pi and 2 pi, that's 3 pi over 2, right? 1.5 pi. So these are the angle measurements for the axes, plus and minus. Now we will have to, on the next slides, we will have to convert from one unit of measure to the other. And the way we do that is using this equivalence right here. 180 degrees is the same thing as pi radians. Right, so here's the next side. Right, in order to convert from degrees to radians, multiply by pi over 180. And in order to convert from radians to degrees, multiply by 180 over pi. So I hope that this inserting of recording works. I'm going to stop the video now, and let's see.
Okay, so we're going to use 180 degrees equals to pi radians. So if you want to go from degrees to radians, multiply by pi divided by 180. If you want to go from radians to degrees, multiply by 180 divided by pi. So convert 125 degrees to radians. So we're going to take 125 degrees, and then which one of those two we're going to multiply by? You're going to multiply times pi divided by 180 degrees. So you need it in that way, right, with the degrees in the denominator, so that the degrees in the numerator cancel with the degrees in the denominator. And then the pi, which is in radians, is in the numerator. That'll be the units of this answer. Okay, now, usually the way you do these kind of problems is like this. You're going to say 125 divided by 180 times pi. You know, leave pi like it is. And then simplify the fraction, right? How can you simplify 125 over 180? Okay, that's 25 over 36 pi. So a lot of times they'll say, like, you know, what is it in radians, you know, in terms of pi, meaning that you want the pi to be there. Don't just like turn the whole thing into a decimal. Just simplify that fraction and keep the pi where it is. Okay, now if we go the other direction, right, what do I need to multiply by to convert negative pi over 12 radians to degrees? Times (180) degrees divided by pi, right? Which is pi's in radians. So you could, it's like I say, it's like an invisible unit, but that radians in the numerator here cancels with the radians in the denominator there, and we're going to get an answer which has degrees as the unit. Okay, now the pi's are going to cancel, right? And so this is going to all come down to negative 180 degrees divided by 12, which is negative 15 degrees. Okay, so in order to go from one to the other, all you need to remember is that 180 equals pi. Just, you know, just one or the other. Just figure out which one goes on top, which one goes on the bottom. So try to do that one. Let me multiply this first one by. Right. This one was times pi over 180. Right, what was this one? 5 pi over 4 times 180 over pi. Okay, so what is this first one? That ends up being 3/4. 3/4 times pi, or 3 pi over 4. Okay, how about the second one? The pi's cancel, 4 goes into 180, 45 times, 5 times 45 is 225 degrees. Okay, so 5 pi over 4 is the same thing as 225 degrees. 135 degrees, same thing as 3 pi over 4. Okay. So next, the unit circle. So now we're gonna show you the unit circle, which is something that's used in trigonometry forever. In fact, I'm using the copy I'm going to give you right now is like something I've been handing out for years. Unit circle. By unit circle, we mean a circle that has a radius of 1. Unit means 1. Okay, that's what it is, the unit circle. Right? Center at the origin. Okay, you can see because you got the blank copy in front of you that it's got a place. You can see on the inner part of the circle, there's got a place here to write all the angle measures in degrees. And then there's a spot next to that, between that and the outside of the circle, which is for radian measure. And then you've got where all of those lines intersect with the unit circle, you've got a place for the coordinates of that point. And like was on the last slide, in fact, the coordinates of these points, right, the x coordinate, well, I'm gonna do this just a little different than I did before, just to show. Let's say that I drop a line right there to make myself a right triangle. And then this is actually going to be the 30-degree line right there. And what did we say is the radius of the circle? It's 1, right? So this is a 1. So you can see the x-coordinate of that point, the x is the length of this side of the triangle, and the y is the length of that side of the triangle. So if I wanted to find the sine of 30 degrees, I would have to do the opposite over the hypotenuse, right? And I would get y over 1, so it is this going to be y. So what that tells you is that the y coordinate equals the sine of the angle. Y coordinate is the sine of theta. If I wanted to find the cosine of 30 degrees, I would get the adjacent x divided by 1, so x equals the cosine of theta. What if I wanted to find the tangent of that 30-degree angle? What would it be? Y over x, right? It's the opposite over the adjacent. So these three we use, right? Tangent equals y over x. You know, it's made easier for the sine and the cosine because the hypotenuse has got a length of 1. So you're just dividing by 1. So x equals the cosine and y equals the sine. Okay, now let me get rid of this stuff here. So we're going to fill this out now. It'll take us 5 minutes, maybe 10 minutes to have all of that filled in, and then certainly on a quiz or test, you're going to have to reproduce this whole thing. You can count up how many separate pieces of information there are. I think it's 66. But you don't want to remember it like it's 66 disconnected pieces of information. In fact, it all kind of fits together. So, for example, if I want to do the degrees here, let me start with filling in these degrees going all the way around. I know that this is 0 degrees, and it's also 360 degrees. I know that this is 90 degrees. This is 180. This is 270. Okay, now halfway between 0 and 90 should be this middle line right there. So that should be 45. Halfway between 90 and 180 should be this middle of the quadrant line. What is that? 135. Right? Halfway between 180 and 270, 225. halfway between 270 and 360. 315. Okay. Now on either side of those middle of the quadrant 45-degree lines, right, you've got a 30 degree and a 60 degree. So this is the 30 degree. This is the 60. Right? This one is 30 degrees past 90 would have been 120. And this would be 150. All right, this is going to be 30 degrees past 180 is 210 and 240. And 30, this would be 300 and 330. So everybody should be able to repeat those. Just go all the way around the circle. Okay, now we got to do the radians. Some of the radians we kind of already know. We know on the axes what the radians are. So 0 degrees is 0 radians. 360 degrees is 2 pi radians. Right? I know that straight up and down, 90 degrees, that's pi over 2. Straight to the left is pi. And straight down is 3 pi over 2. Okay, so now we've got to do these others. Well, with the 45 degrees is halfway between 0 and 90 degrees. So what's halfway between 0 and pi over 2? Pi over 4. So that's easy enough, pi over 4. Right? And now if I just go in increments of pi over 4 going around the circle, right? 1 pi over 4. 2 pi over 4, that's pi over 2, right? 3 pi over 4. Then add another, 4 pi over 4, oh, that's pi. 5 pi over 4. Okay, add another, 6 pi over 4, okay, that's 3 pi over 2. 7 pi over 4. And if I added one more, I added 8 pi over 4, which is 2 pi. That's all the way around the circle. Okay, now, 30 degrees. We could, go back to the last lesson where we had, we did the sine and cosine of 30 degrees. Right? We actually already did that. Or you could use what we just did in the last few slides where we convert from one to the other. What is 30 degrees in radians? What would I multiply by to figure that out? Pi over 180, right? So that's going to be 30 over 180 times pi. What's 30 over 180? 1/6. So actually this is going to be, this is pi over 6. Okay, now 60 degrees should just be double that, right? 2 times 30 is 60. 2 times pi over 6 is? Right? 2 pi over 6 is pi over 3. Right? Then I can go 3 pi over 6 would be pi over 2. 4 pi over 6 would be 2 pi over 3. Simplify the fraction. Right? 5 pi over 6. Okay, that one we got to keep. 6 pi over 6 is pi. 7 pi over 6 goes here. 8 pi over 6 would be 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. And then 11 pi over 6 goes here. Okay, so now we did all the angles going all the way around, and that should be a fairly easy process to just get those laid in there. Okay, now we have to fill in the coordinates, right? The coordinates. So since this is a unit circle, the radius of 1, right straight to the right on the positive x-axis, that's 1, 0. And if it goes straight up and down, 0, 1. Right? If it goes straight to the left, negative 1, 0. Straight down, 0, negative 1. Okay. So now we need to know what are the sines and cosines, the sines and cosines, basically, the x's and y's for 30, 45, and 60 degrees. Again, we did this last class. Does anybody have that handy? What was the sine and cosine of 45 degrees? It was the same thing. I can open it up. This is what we did last time. 13, 1, 4. So the sine of 45 degrees was the square root of 2 over 2. The cosine of 45 degrees, square root of 2 over 2. So we can fill that one in, right? That'll be the square root of 2 over 2. The square root of 2 over 2. Okay, let's do the 30 degrees. 30 degrees came from the next slide. The sine of 30 degrees is 1/2. That's the y coordinate, right? The cosine of 30 degrees is root 3 over 2. That's the x coordinate. So we should fill this in. Root 3 over 2, 1/2. Okay, now we need the 60 degrees. Right, 60 degrees was here. And remember, the sine of the 60 degrees was the same thing as the cosine of 30 degrees. And the cosine of 60 was the sine of that. So now we're going to get, instead of root 3 over 2 comma 1/2, we're going to get 1/2 comma root 3 over 2. They just switched coordinates here. So this is 1/2 root 3 over 2. I mean, when you have to place it, these are the only values that we're going to deal with. We have to fill in some more going around the circle, but they're still only going to be these numbers. Sometimes they got a minus in front, sometimes they don't. You know, they go in order. Like the y coordinate is telling you how far are you above the x-axis, right? So it starts at 0, right? Then it goes to 1/2. Then it goes to root 2 over 2, which is more than 1/2. The square root of 2 is like 1.4, which is bigger than 1, right? Then it goes to root 3 over 2, which would be bigger than root 2 over 2, and then it goes to 1. So, I mean, you can basically just place these in order. Just go from 0 to 1, and then go back the other way. 0, 1/2, root 2 over 2, root 3 over 2, 1, right? Now, the pattern's going to continue going around the circle. It just that, you know, x is positive over here, but it has to be negative over here, right? Y is going to be negative if the y coordinate is below the middle. So other than that, we can just spread these. I mean, you could do it different ways. Like you could say, like this point here, root 3, at 30 degrees, if I take that straight across, then it should be the same thing except for now the x is negative. Negative root 3 over 2, comma 1/2. Right. If I went from this 30 degrees here, if I went straight down to here, what is it that changes sign? And when I go from 30 degrees to 330 degrees, so the y is now going to be negative, right? So I still stick with the positive root 3 over 2, but now it's a negative 1/2. And then the last one of those, like if I went straight down from 150 degrees, that would be 210 degrees. Okay, now in the third quadrant, both of them are going to be negative. So there's a negative root 3 over 2. Negative 1/2. Okay. So you could do that just spreading them around. You could also, like I said, if I just start here, I'm at pi degrees, pi radians, 180 degrees. If I start with 0 there, then this is 1/2. This is root 2 over 2. This is root 3 over 2. And then this is 1. And then I go to the x-coordinate. 0, now their x's are negative, so negative 1/2. Negative root 2 over 2. Negative root 3 over 2, negative 1. Okay, now we can do the same thing going into the third quadrant. Start with pi 180 degrees, 0, negative 1/2, negative root 2 over 2, negative root 3 over 2, and negative 1. And then go back from 0 at 270 degrees to the left. 0, negative 1/2, negative root 2 over 2, negative root 3 over 2. And then in the fourth quadrant, right, start at 0. 0 for the x-coordinate. 0, positive 1/2, positive root 2 over 2, positive root 3 over 2, and 1. 0, negative 1/2, negative root 2 over 2, and negative root 3 over 2, negative 1. So that's the entire unit circle. Now, these numbers, they all came from what we did in the last lesson using the special right triangles. We know what the sines and cosines are of all of those. So at this point, using the unit circle, we ought to be able to say, for example, let's say, what is the sine of 2 pi over 3? Okay. Then you would go to 2 pi over 3, which is right here. And because it's the sine, you're looking for the y-coordinate. And you would say root 3 over 2. What is the cosine of 315 degrees? Right? You would say, okay, where's 315 degrees? Which quadrant? 4, right there. Okay? The cosine would have been the x-coordinate. So you go down there, look at the x-coordinate. Positive root 2 over 2. What if I said, what is the sine of negative 90 degrees? Is negative 90 on there? But it's coterminal with which angle, which is here? 270, right? Negative 90 would have taught you just straight down. So the cosine of negative 90 would be 0. What if it said, what is the tangent of pi over 4? Remember, what did it say about the tangent right there? It's y over x. Okay, so pi over 4 is right here. What is the square root of 2 over 2 divided by the square root of 2 over 2? 1. Right? Anything divided by itself is 1. So now, using the unit circle, we should be able to answer all those kinds of questions. Again, you should have enough knowledge of this. That, you just think about it in your head. Okay, which quadrant does that put me in? What are these numbers? There's only like say, how many different numbers are there? 1, 2, 3, 4, 5. It's either 0 or 1, 1/2 square root of 3 over 2, or root 2 over 2. Those are the only possibilities. Root 2 over 2 always goes with itself, right? 1/2 always goes with root 3 over 2. So, okay, don't stop on me. That's the unit circle then. That's all filled in. Now, the other thing you notice is they've put up in the corners there, positive and negative for which one of the trig functions are positive or negative in that quadrant. Like in the first quadrant, everything's positive, right? Which makes sense. If you go to the second quadrant, because the x-coordinate is negative in the second quadrant, the cosine has to be negative. And if the cosine is negative, then when you go the y divided by x, the tangent's got to be negative too. So the cosine and its flip, secant, are negative. The tangent and its flip, cotangent, they are negative. Right? In the third quadrant, both x and y are negative. Right? So that means the sine is negative, the cosine is negative, the secant is negative, the cosecant, because those are just the flips of the sine and the cosine. But the tangent is the y divided by the x. That's a negative divided by a negative. That's a positive. So tangent is actually positive in these two quadrants, right? And cotangent also, right? If you go into the fourth quadrant, now the x is positive, but the y is negative. So cosine, positive, secant, positive, sine, negative, cosecant, negative. Tangent, because it's y over x, if just one of those is negative, then it's got to be negative. Okay. So you should have that now, right? You wrote it out all out. So use the unit circle to exactly evaluate the 6 trig functions for theta equals 135. Okay. So when I do these kind of problems, to me, first thing I'm going to go to the unit circle. Let me erase my writing from before. Find the angle that you're interested in. So we just said 135. Where's 135? Right there. Okay, so what you need is the coordinates. You need the coordinates of that point. So it's negative root 2 over 2, positive root 2 over 2. So let's write that down right there. So the point that we're looking at has got coordinates of negative root 2 over 2, positive root 2 over 2. Again, what are the things that we know? We know that the x equals the cosine, the y equals the sine, y over x equals the tangent. Okay, so we're going to start. The sine of theta equals positive square root of 2 over 2. The cosine of theta equals negative square root of 2 over 2. The tangent of theta equals what do you get if you divide positive square root of 2 over 2 by negative square root of 2 over 2? Negative 1. Right? Then you got to do all the flips. Right? The flip of the sine is the cosecant. What's the flip of square root of 2 over 2? Square root of 2. What's the flip of negative square root of 2 over 2? How about negative square root of 2? Again, if you go back to where we did this, you can see where we flipped this. Here's where we flipped the sine. Here's where we flipped the cosine. These are all the same values. Okay, what about the tangent, cotangent? What do you get if you flip negative 1? Negative 1. 1 over negative 1 is negative 1. Okay, try that one. See if you can come up with, use the unit circle to find the exact trig, the values of the 6 trig functions for negative pi over 3. Now go back to the unit circle. Negative pi over 3 is not on the unit circle. How are you going to find a coterminal angle that is? Do you see positive pi over 3? Okay, so positive pi over 3 is just a simple way to do it. It's 3 lines up, right? One in a counterclockwise direction. 1, 2, 3. So where would you go to find negative pi over 3? How about 3 lines down, right? 1, 2, 3. Looks like you're looking at this angle right there. I mean, the other thing you can do, which is not necessary to do this much work, is you could just take the negative pi over 3. Since that's not between 0 and 2 pi, then add 2 pi. That would take you exactly 1 time all the way around the circle, right? Negative pi over 3 plus 6 pi over 3, which is 5 pi over 3. And that again is right in the same place. So this is the point that you want to use. without actually looking at the unit circle. I mean, I've done many of these when as a student, as a teacher, whatever. In my mind, when it says like use the unit circle, I mean, I don't actually like use that unit circle. In my mind, I'm trying to picture. I usually draw myself a little circle like that. Say, okay, negative pi over 3. That one, I know that angle is like right there, right? It's closer to the straight down than it is to the positive x-axis. So that's going to have coordinates that are like, it's not the root 2 over 2s, because they go together in the middle of the quadrant. This is the one where it's the 1/2 and the square root of 3 over 2. Okay, but the square root of 3 over 2 is bigger than 1/2. So it makes sense. This thing is farther down than it is to the right. So the 1/2 has got to be first. And the root 3 over 2 has got to be second. And then because it's in the fourth quadrant, actually that's negative. So you just, without actually looking at the unit circle, I would be doing that. And I mean, I always have all these circles drawn like that, where I've tried to picture where I'm at. And then from there, you just put it together, right? Sine, what was the sine? Negative square root of 3 over 2, right? Cosine, 1/2. Tangent. Again, these are all the same things that we did in the lesson last time. Sine over cosine, or y over x, negative square root of 3. Right, then we have cosecant. Is the flip of this, which is, again, we did this yesterday, negative over 3, right? And the secant, 2. And the cotangent, if you flip it, you get negative 1 over the square root of 3, and you rationalize, you get negative square root of 3 over 3. Okay. You okay, Hannah? Okay. Okay, so use the unit circle to exactly evaluate. By exactly, it means like don't just put it in the calculator. You could put the negative 240 degrees in the calculator, right? It's just going to turn it all into a decimal. We want those square roots of 3 over 2 and things like that. So let's see, where's negative 240 degrees? If you're not familiar with it, how about we do, what is negative 240 plus 360? $120 degrees. So that's where you want to look on the unit circle, right? 120 degrees, again, if I draw this, don't do this to me. Draw my little circle. 120, that's 30 past 90. That's right there. So again, that's going to be root 3 over 2 and 1/2 in some combination. Looks like it's negative 1/2, positive root 3 over 2. Right? It's farther up than it is to the left, since it's just 30 degrees past straight up. Okay? And we don't need everything here. We just need the tangent. The tangent should be the y divided by the x, which is root 3 over 2 divided by negative 1/2, which is negative square root of 3. How about 17 pi over 6? Is that on the unit circle? So how can I find the coterminal angle, which is on the unit circle? How about subtract 2 pi? Right? That'll be 17 pi over 6 minus 12 pi over 6, which is 5 pi over 6. And 5 pi over 6, I know, just 1 pi over 6 less than pi. That's right here. And the coordinates of that point are, let's see, it should be negative square root of 3 over 2 and positive 1/2. So we want the cosecant. What's the definition of cosecant again? Not the opposite. The reciprocal, right? The reciprocal of the sine is the cosecant. So we should do the cosecant of 17 pi over 6 is the same thing as the cosecant of 5 pi over 6, which is equal to 1 divided by the sine of 5 pi over 6. Right? Which is 1 divided by, the sine is 1/2, which is 2. Okay. So try to find the cosine of negative 210. And if you don't know where the negative 210 is, add 360. See what you get. Where do you find negative 210? So negative 210, I can do a negative 210 plus 360. That's 150 degrees. Right? That's easy enough to find. That's actually the same place we just were. Right? So 150 degrees. So we're using those same negative root 3 over 2, comma, 1/2. So what is the cosine? Negative root 3 over 2. Done. Okay, last but not least. It's actually like the first thing in this section, but I moved it to the end because I just don't think it fits well with the rest of that stuff. But so let's say you have a point anywhere in the coordinate plane now. It's on the terminal side of the angle, and you want to evaluate the 6 trig functions. Then you do something like this. Plot your point. So 1, 2, 3, 4. 1, 2, 3. So there is negative 4, 3. Right, the terminal side of the angle is this. Right, now the angle, if that's the terminal side, that means, you're either going around that way or you're going around that way. Ultimately, you're going to do this with right triangle trigonometry. So we won't worry about this angle here, like starting from the initial side and going around. Make yourself a triangle with the x-axis. No matter where you are in the coordinate plane, if you're just given a point that's on the terminal side, make yourself a triangle with the x-axis. That means the theta is going to be right there. Right? The theta is always with the x-axis. Okay, now you can say what the lengths of these sides are, right? The length of this side is 3. The length of this side is 4. If I want to know the length of the hypotenuse, what am I going to do? Pythagorean theorem. Well, this is the Pythagorean triple, 3, 4, 5, right? So that's a 5. And then because this x is negative, right, is going in a negative direction, we're going to put a negative 4 on that. So now it says find the 6 trig functions. Okay, with that triangle, the sine should be the opposite over the hypotenuse, 3/5. The cosine should be the adjacent, negative 4/5. The tangent, opposite over adjacent, negative 3/4. So then we do the flips. Cosecant, secant, and cotangent. So the flip of 3/5 is 5/3. Negative 5/4. And negative 4/3. Yep. So last, try to do that one. So what was the length of the side? Yeah, you had to do Pythagorean theorem to find the third side. It was 13. Right? And then fill them all in. Right? Sine should have been negative 12/13. Cosine, negative 5/13. Tangent, positive 12/5. Right? A negative divided by a negative is a positive. And then you flip them all. Negative 13/12. Negative 13/5. 5/12. I think, right? Okay. That's it. Sorry it's long.